Welcome back to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we explore the cutting edge of science. And with us today is an astronomer. We have with us Professor Eric Aspog, author of an exciting new book called When the Earth Had Two Moons. Cannibal planets, ice giants, dirty comets, dreadful orbits, and the origins of the night sky. So today we're going to talk about the origin of the solar system. You know, when you look at the moon and the planets, they seem so ordinary, so calm, serene. But did you know that about 4 billion years ago, we had collisions, titanic catastrophes. We had planets eating up other planets. We had objects spewing out all sorts of junk. And so with us today is an astronomer to talk about when the moon was first formed. Where did the moon come from? What's the future of the moon? And for that matter, what about Venus, Mercury, and Jupiter? Well, once again, with us today is Professor Eric Aspog. He's a professor of planetary science at the University of Arizona, author of this new book, When the Earth Had Two Moons. So, Eric, first of all, tell us a little bit about your youth. When you were a kid, what sparked your interest in science and then astronomy?
Well, one of the first things I remember about being interested in planets was my parents had this big, huge atlas of the Earth. And back in the 60s, there wasn't a whole lot known. I mean, we had images of the far side of the moon by then, and the space program was going strong, and Gemini was in the sky. The space program Gemini, that was the precursor to Apollo. But I had this big fat book, and in the back of the book was this speculation about how the planets had formed. And you don't have to go back too far. And we thought that another star had collided with the sun and spewed out a string of planets. That was the planet formation theory back then. And it's wrong, but I thought this was so fantastic and so weird, and the color pictures were so phenomenal that something just kind of stabbed me in the gut. It was like, wow, this is really interesting. And maybe I thought, you know, it was possibly wrong because it seemed so strange. But I always had a scientific mindset. And the next outdoor activity, I remember being introduced to a telescope, and I was probably about 5. And I remember having to climb up these rickety little steps to get up to be able to see through this fairly small telescope, but I was a tiny little guy. And I remember seeing Saturn for the first time. And the first time I'd ever seen a planet. And I think if your listeners have never taken out a telescope and looked at Saturn, it's out there free to look at. And there was something about the reality of it, to see something through the eyepiece of a telescope that looked so beautiful. And I've just sort of took off in that direction ever since.
And some parents wonder, what kind of telescope should I buy my kid? I mean, sometimes when you shell out a ton of money and buy a telescope, the kids lose interest in it. So some people say, well, why not buy some binoculars at first? And then when they get more serious, then you can buy your kids a real, let's say, reflecting telescope. But what are your thoughts?
Well, that's great advice. I'm reminded of, I think every kid has had a really crummy telescope, right? That costs $65. Then you look through it and you can't see anything. And there's sort of a reason why it took not just Galileo, but you go to Robert Hooke, who was a famous philosopher and scientist, and it was about 60, 70 years after the first telescopes. He had a really good telescope, and he started to see things that people hadn't seen before. And I'm kind of reminded of my mother. She once bought me a guitar because I was interested in playing guitar, and she bought me a terrible guitar. No fault of her own, but she didn't know. She's from Norway. She didn't know that they'd sell guitars that weren't meant to be played. They were decorative guitars. And so I spent my first couple of days trying to bang on this thing strung with, baling wire, and decided guitars were horrible. So don't let that happen to your kids. Get them, spend a couple of $100, and if you can't do that, go to a star party, because you find on weekends amateur astronomers are dying to get people to look through their $10,000 telescopes, and you get to have a real show.
And I understand on the internet now you can actually get into people's websites and actually see the telescope on the screen of your laptop in real time. So people could actually share the experience of looking at the moon and the stars via the internet, right?
Well, that's true. It's not the same as having the photon. The same photon hits you in the eye. I guess you know a lot better than me about that, the physics of all that. But the streaming from the sun, the photons reflect off of Saturn, come back into your eye maybe a half a day later for the whole journey, and you've got yourself some genuine reality to that picture. I'm a little bit. I used to be really interested in getting into astronomy just so you could go to the dome and be out there in these wild places and do astronomy. More and more people are sitting there guiding the telescope on a computer screen. You get the same data, but I think there's something kind of visceral about really looking at it through an eyepiece. It's kind of like sort of almost a steampunk kind of a feeling about it.
Okay. Well, let's jump right into the substance of your book, When the Earth Had Two Moons. So first of all, where did the moon come from? And what did we learn from moon rocks, hundreds of pounds of moon rocks that our astronauts brought back?
Prior to Apollo landing on the moon, there were split camps about what the origin of the moon was. You can measure the mass of the moon by its orbit around the Earth, and so we had known for a couple of hundred years that the moon's less dense than the Earth. It weighs less than the Earth compared to how big it is, and so it's made of different stuff. And so some people thought it was a captured asteroid of some kind, a primitive object that formed originally around the Earth, perhaps. That mathematics would never work out, kind of the way that the mathematics of the planet-forming scenario where the sun crashes into our sun, that could never work out. And so math backs you into a corner, and you can't get the scenario to make sense of how the Earth could capture a big primitive object around it without having it collide into the Earth. And it's kind of funny that people were dancing around this notion of a collision for quite some time, but it didn't really fit into anybody's mindset that you could have planets actually crashing into each other, getting so out of whack after solar system formation that you'd have a Mars-sized planet. Now, this is the modern theory, a Mars-sized planet crashing into the proto-Earth and creating this enormous debris disk around the Earth that would be mostly made out of the rocks that are the surface materials and the mantle materials. All the iron of these planets are in the core.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, with us today is Professor Eric Aspog, author of the book When the Earth Had Two Moons. So we're talking about the origin of the solar system. Now, Eric, when I was a grad student at Berkeley years ago getting my PhD, I saw moon rocks under a microscope at the Rad Lab there. We actually got some moon rocks from NASA, and I had a chance to peer at moon rocks in a microscope, and I was stunned. I saw, of course, micro craters inside the moon rock, but inside the craters there were smaller craters. Inside those smaller craters were even smaller craters. Craters inside craters inside craters. And then I realized, of course, the moon has no atmosphere to burn up micrometeorites. Now, of course, we've analyzed the chemical composition of these moon rocks, and as I understand, we find out that is very similar to the Earth. And so, in other words, did the moon come from the Earth?
It's the $64 question right now, because this theory that the Mars-sized planet hit the Earth and made a disk from which the moon formed, that fits all the stuff about these moon rocks. They are igneous, meaning they formed from a melt, and they crystallized from a melt, and so you have this, instead of a primitive object captured by the Earth, you have this magma, they call it the flying magma ocean, orbiting the Earth that solidifies to form the moon, and so it's a big ball of lava that solidifies. And then when you look at these samples, you see igneous textures, volcanic rocks pitted by all these craters. But what's interesting is compositionally, when you look at the really detailed composition of moon rocks, it's as if you took a piece of the Earth's mantle and threw it into the sky, not just in terms of bulk composition, but what we call isotopic composition, the really detailed constituents of all the elements. And that flies in the face of the model, because the model, when you run it on a computer simulation, the moon gets made out of this alien planet that collided into the Earth. And so the moon should be different in terms of this sort of crime scene investigation approach. And it looks like it's made of almost the same material as the Earth, with a couple of small differences. Now, it's lost its water. It doesn't have an iron core. These can all be explained by it forming in a giant impact. But the fact that it forms almost entirely out of the Earth has been a real fly in the ointment for this theory of the giant impact. And so in the last 20 years, you've had this reconciliation trying to happen, with people coming up with extraordinary theories. Our latest theory, for instance, is that there wasn't just one giant impact, but there were two or three involving the same two bodies that kept coming back again and again, trying to connect. And it was only on the second or third try that the crash actually happened that made the moon.
Now, our astronauts left a mirror on the moon, and we shined laser beams from the Earth to the moon, bouncing off that mirror, allowing us to calculate the rate at which the moon is leaving us. And so the question is, how fast is the moon leaving us? And does that mean if we run the videotape backwards, that the moon really did come from the Earth? But what are your thoughts?
Well, it's moving at about the speed that your thumbnail grows, about 4 centimeters a year, which is also about the rate of plate tectonics on the Earth, coincidentally, the movement of the continents around the surface of the Earth. So these are very, very slow rates, but they accumulate over geologic time, over millions of years, billions of years. And in the early paleontological studies, it was observed that the numbers of days in a cycle in like a clamshell, which would go through an annual cycle of growth, you'd count about 400 days in a year. And this was known to George Darwin, the son of Charles Darwin, who was George Darwin was one of the great geophysicists, actually overshadowed by his father, but he was one of the first astrogeophysicists, and he reasoned that if the days were shorter, that means the Earth must have been spinning faster. What could be spinning the Earth down? Well, he reasoned correctly that it's the same force that's causing the Earth to spin slower and slower a little bit every year that's ratcheting the moon into higher and higher orbits, 4 centimeters per year. It's all due to the tides that the moon raises on the Earth, then the Earth spins, and that tidal bulge serves to ratchet the moon up into higher orbit. And it's a very elegant theory, and if you evolve it backwards in time, which he did, he got the wrong answer quantitatively. He figured that the Earth and the moon would have been in the same place, whatever that means, would have been like in the same place. The moon's orbit would have been at the surface of the Earth about 56 million years ago. He got the wrong answer because tidal evolution varies as oceans come and go, and as the interiors of planets change, that tidal force can be greater or less. But that sort of led to this scenario back in the 1870s. Really early on, Darwin was a creative genius in this sense. He thought the Earth had once been spinning so fast that the moon just popped out, like just spun off of the side like a lump of clay on a potter's wheel that's spinning too fast. Now we're trying to reconcile what that means. Obviously, in modern terms, that spin was induced by the giant impact that we think happened. But right now it's still quite a mystery when you rewind the tape all the way back.
Okay. Now, also, let's dispense with some conspiracy theories before we go on to your title of the book, When the Earth Had Two Moons. Some people think that the moon program was fake, so let's just really quickly demolish that theory. First of all, when the astronauts put a flag, the American flag, in the moon, it's fluttering. And since there's no air on the moon, people say, aha, it's fake. It was done in a Hollywood laboratory. So how is it possible that that famous picture of our astronauts on the moon has a fluttering flag?
Well, they wanted the flag to be visible, so they put a little bit of structure into the flag so it could hold out at a bit of you could have an expanse of stars and stripes that people could see. Gravity on the moon is very low. It didn't take much of a wire to put into that flag to be able to see it.
Okay, and some people say if you look very carefully at some of the photographs, you see not one set of shadows, but two sets of shadows. Therefore, it was obviously done in a Hollywood studio where they had multiple lights casting multiple shadows. But doesn't the Earth also create a shadow on the moon? What are your thoughts?
Yeah, you have Earth lights. If you think of walking around under a full moon and you can see your shadow under a full moon, well, on the moon, the Earth is 10 times the size in the sky, more than 3 times the diameter, so it's about 10 times as bright. Plus, it's intrinsically much brighter with clouds and oceans, so the Earth is this intense beacon up in the sky when you're walking around in the moon. So, yeah, you have 2 light sources. You have the sun, and then you have the Earth, and then you have a lot of shadows that come in from hitting the angles of the nearby hills. And then you also have the fact that astronauts started to get extremely dusty as they were walking around on the moon, and their legs from about the knees down would become black with dust. And so that can look like a shadow as well. So all these kind of geometries, when you put it together, there's nothing really remarkable about it any more than any other image that you'd take going out on a camping trip.
And for that matter, isn't it true that even small countries and developing nations, India, for example, they've sent probes to the moon. So isn't it true that going to the moon is not really the problem? It's bringing the astronauts back from the moon. That requires a superpower. But to go to the moon is actually rather commonplace now, right?
Yeah, flying in orbit around the moon is something that's getting to be on the verge of the capability of a student team. Like if there are any students out there in engineering or science departments or high school kids wanting to get into these fields, getting a payload to the moon is becoming something commercially commonplace. It's not quite like Pan Am Airlines in 2001: A Space Odyssey. If you remember flying in a sort of a modified airplane jet to go to the moon, but getting a small payload to land on the moon and do lunar science is something that's in the realm of possibility for somebody who's in their teens to get that done by the time they're done with college. The reason is NASA's putting a lot of effort into this, other space programs around the world, and it's miniaturized technology that's borrowed from small satellites, CubeSats, you might have heard of, where payloads can be delivered. You can get your own data back from the moon.
Back to Science Fantastic with Professor Michio Kaku. Today we're talking about the early solar system. Did you know that the early solar system was a violent place with objects plowing into each other, with planetesimals eating up other planetesimals? It was a very violent place. And if you don't believe me, just look at the moon. Look at all the craters, gigantic craters you see on the moon, many of them dating back to that era 3-4 billion years ago. Well, with us today is Eric Espog, author of the book When the Earth Had Two Moons. So, Eric, we talked about the fact that moon rocks show that the moon consistency is very similar to the Earth. Tidal forces indicate that the moon is leaving us at a certain rate. All of that seems to indicate that the moon was blown out of the Earth with a collision. And then the question is, well, when did the Earth have two moons?
It happened we have this era of computer modeling that's advanced a lot in the last 20 years where we come up with ideas and then we see if we can reproduce them in a computer simulation. And for better or worse, that drives a lot of science right now. And so in the computer simulations of the moon-forming giant impact, which work quite well in explaining the origin of the moon, you don't just pop out a moon, you pop out this disk around the Earth that's very massive, maybe twice the mass of the moon, which is about 1% of the mass of the Earth, and that forms a clump. And that clump creates its own gravity field, which causes another couple of clumps to form. And so it's very typical in these simulations to see a couple of moons within a few thousand years of the giant impact itself. And so if you were to take a snapshot of the world around you after the giant impact into the Earth. Let's say you were sitting on one of the floating continents on the Earth after this calamitous event, and you looked up at the sky, you'd actually see a moon about the size of our moon, but about 20 times closer, so it'd be 20 times bigger. And then you'd see a couple of other moons leading it and trailing it. One of them would probably be a lot bigger than the other. And so the notion of these two moons were really debris left over after the giant impact. And the story of the second moon is the story of what happens later as these two moons, maybe three, are evolving away from the Earth due to tides. And then one day they get into trouble and they collide and merge together. That's the basic two-moon scenario, is that you have a late, huge collision into the moon itself by a little piece of its own lost debris, like its own cousin coming back home.
Now, if there were so many gigantic collisions of objects the size of Mars, there should be scars, gigantic scars in the composition of the Earth itself. Gravity, of course, makes the Earth round because gravity then attracts other objects evenly. But once upon a time, the Earth was not round, so shouldn't there be evidence of the scars from all these titanic, catastrophic collisions? What are your thoughts?
Well, the bigger the planet, as you say, the more it's going to recover from these wounds. And so you could have a planet the size of Saturn hit Jupiter, and after a few thousand years, it would be hot, but it would still be perfectly spherical. You could have a Mars-sized planet hit the Earth and make the moon, and then once the Earth solidified, there'd be almost no record of it in the Earth itself, other than chemically.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, we're talking about the violent history of the early solar system, the origin of the moon, the origin of the solar system 3 to 4 billion years ago. With us today is astronomer Eric Aspog. The book is called When the Earth Had Two Moons, Cannibal Planets, Icy Giants, Dirty Comets, Dreadful Orbits, and the Origin of the Night Sky. Eric, let me ask you a question that's been bothering me for a while. When you look at the spin of the planets, they all, of course, are spinning in this disk, the ecliptic plane of the solar system. But when you look at Venus, it spins backwards. So that shouldn't be right. I mean, all the planets should be spinning in the same direction, in the same way, because we all came out of the same primordial protostar that eventually became our sun. So was it possible that Venus, an object the size of the Earth, once upon a time had a titanic collision that reversed its spin? What are your thoughts?
Venus's retrograde orbit is fundamentally mysterious because not only is it rotating backwards, but it's rotating backwards so slowly that the planet's almost at a dead stop. It's bizarre. And if you were to try to explain that by a collision, it would be kind of like throwing a baseball at a basketball that's coming at you and then having the basketball just stop. It would have to be a really, really balancing act to get it to not be rotating. And one of the ideas about the origin of Venus is that maybe it, too, once had a giant moon, possibly formed in its own giant impact, and then the moon was evolved away from Venus, removing the spin of Venus the way our moon is removing Earth's spin. We're spinning slower and slower with every year, just, by a hundredth of a second. But over time, that might have accumulated enough that Venus was stopped. But I would say that this strange nature of the spins of the planets, if you plot them up, they are in, some of them are in the ecliptic, some are out of the ecliptic, like Uranus spins at 95 degrees. It actually spins a little bit, sort of like edge onto the ecliptic. This has led to a kind of a cottage industry of giant impact modelers trying to explain each spin state of each planetary system as the result of some final giant impact. And so my feeling about the origin of planets is that you had this regular process, kind of like star formation. All the yellow stars are about the same size and mass. All the red stars, their stars have their own differences, but they're more similar than they're different. And then you had this icing on the cake where the planets started to bash into each other chaotically. And enough of these events that you sort of created discrete representations of all the different possibilities. And so how did the Earth get to be, which I think is the key mystery? You give it enough try, and you give it enough random elements at the very end, and every once in a while you come up with just the right mix.
Okay, now, in your book, you mentioned something that I first heard about years ago reading Scientific American. In that article, it said that 1,000 years ago, there was a monastery where some of the monks recorded the fact that the moon was on fire. They looked up and they saw flames and smoke coming from the backside of the moon. Lasted a few days, and then it just disappeared. And not just one, but several people recorded this sighting, but only in Europe, not in Asia, not in China or Japan, anywhere else. So tell us a little bit about the fact that is it possible that in recorded history there was a titanic collision on the backside of the moon sufficient to create the illusion that the moon was on fire? Any thoughts?
Well, you give it a Sherlock Holmes approach, and you say with deductive reasoning, what would it imply if this had happened? If a collision had hit the moon with enough intensity to be brightly visible by astronomers in Europe and England, what would that imply? It would, and it was tied in the 1970s to a crater on the moon called Giordano Bruno crater, which is 20 kilometers diameter, and which is a very young feature on the moon. And so people ran with this idea for a while, and someone said, hey, if you made a crater that big on the moon, wouldn't you eject a bunch of junk into orbit around the Earth?
Welcome back to Science Fantastic with Professor Michio Kaku. Once again with us today is Professor Eric Aspog, author of the book When the Earth Had Two Moons. We're talking about the violent history of the early solar system. And we have this footnote in history that 1,000 years ago, people recorded sighting fire on the moon. A catastrophic event, perhaps a collision, who knows for sure, but flames and smoke coming from the backside of the moon. A few days later, it all disappeared. Some people think that maybe there's a crater on the backside of the moon named after Giordano Bruno. I should also point out that Giordano Bruno himself in the year 1600 was burned alive in the streets of Rome for heresy, for saying that there could be aliens in outer space. Well, thank goodness we don't burn astronomers anymore. But Eric, what are your thoughts about the evidence? Was there fire on the moon 1,000 years ago?
I don't think so. I think it was putting two events together into a single event. I think what they had seen was a shooting star, a meteor, violent meteor coming in that happened to be right in front of the moon. And the reason I think that is because the alternative would have left us with about 3, 4, 5 centuries of incredibly brilliant meteor showers, because you don't just create a crater that size without creating a huge amount of debris. And it's pretty easy to do the math of how this debris, where it would go. Most of it would re-impact Earth. And there's no record anywhere in China, who were keeping extraordinary records at this time. There was no record in China of any such event. And so probably the most economical explanation is that what they saw was a brilliant meteor, happened to be right in front of the moon, not knowing anything about space, because our brains fit things into the patterns that we're used to seeing. They assumed that it was an event that actually happened on the moon.
Okay, well, speaking about computer simulations that you mentioned, if you do a computer simulation of the Earth-Moon system and simply run the videotape millions and millions into the future, you find that it's relatively stable because the Moon, because it's so large, helps us stabilize the spin of the Earth. But then if you reduce the size of the Moon, make it smaller and smaller, eventually the Earth begins to wobble, tumble, turn upside down, do all sorts of funny gyrations. And so don't we depend upon a large moon, that if the moon were smaller, we wouldn't be here, that we need the moon to stabilize the orbit of the Earth so the Earth doesn't spin. What are your thoughts?
Well, we owe our lives to the moon. Literally. I think I'm not a biologist, but I sort of side with the theories that the moon raising and ebbing of the tides in the oceans raised by the moon early on would have been a nice conducive environment for evolution of more complex life forms. But just the basic stability given to us by the moon, you can demonstrate it by just hopping over to Mars. That it has a couple of tiny moons, but it doesn't have anything massive. And the Martian obliquity, that is, how it points relative to the sun, what creates its season. Mars does exactly as you say. It flips around every 5 million years or so. Sometimes the North Pole is pointed at the sun. Sometimes the North Pole is pointed straight up. And so Mars never had a chance to have anything resembling a stable, long-term climate. And so if you're looking for a recipe for a really, really good habitable planet, you not only want it to have an ocean and an atmosphere and all these kind of things, but I think you also want to give it a pretty sizable moon to give it stability for the long haul.
And I understand that if you take a look at the two moons of Mars, run the videotape fast forward millions of years into the future, they'll be unstable and they'll eventually crash into Mars. So our moon is leaving us, but there's some people who believe that the Martian moons are actually going to collapse in the future and crash into the red planet. What are your thoughts?
This is true, and you can actually see it because we can track the orbits of these little moons, and you can find that the little moon Phobos, which is the one that's inside this what's called the geosynchronous orbit, essentially, it's orbiting close enough into Mars that instead of Mars moving it out like Earth is moving the moon out, it's moving this little satellite in. And in about 10 million, 40 million, it's hard to predict exactly, Phobos, which is about 10 miles diameter, it'll break apart, and you'll have a ring around Mars that'll look a lot in the sky like Saturn. It'll be a phenomenally beautiful object. It'd be great to be around to see it. And you can actually see some evidence that this is beginning to happen right now, because if you look at Phobos, it's got stretch marks all over it. It looks like it's beginning to start to come apart. And it's not going to happen anytime soon, but if it got impacted by some garden-variety asteroid, that might be the end of it. It might accelerate the process. And then you'd look back on Mars and you'd see a ring of craters around the planet after the big chunks have fallen in, and then you'd have this debris disk, and the planet itself would get maybe 3-4 times brighter in the sky. And that would be the time to buy this backyard telescope you were talking about.
And speaking about Saturn, there's a theory that says that one of the moons of Saturn got too close to Saturn, and tidal gravitational forces ripped the moon apart, creating the rings of Saturn. And if you take a look at the distance from Saturn to the rings of Saturn, that's more or less called Roche's limit of where you would expect a moon to be shattered by tidal forces. But has that theory held up, the fact that the rings of Saturn might have been caused by a moon that got too close to the mother planet and gravity ripped apart the moon? You got just a few seconds to answer that question.
Well, the only problem with that theory, you can make it work, but if it's going to happen at Saturn, it ought to happen 10 times as often as Jupiter, which is more dense than Saturn and a lot more massive. And so that's one of those things where you say, I can make that happen, but I ought to have gigantic rings around Jupiter, and I don't see those.
Okay. Well, once again, our special guest today has been Professor Aspog. The book is called When the Earth Had Two Moons, and you've been listening to Science Fantastic with Professor Michio Kaku.